Okay, I kind of hinted at a compound inequality yesterday. So we've been talking about inequalities where we could have sets of numbers that could be possible answers, not just one answer. Okay, so a compound inequality for us is going to be two distinct inequalities. And I'm going to abbreviate inequalities, right? Joined by the words, I think you've seen this before, either and or the word or. Okay, so this is going to be our working definition. So a compound inequality is where we're going to take two inequalities and either join them by the words and or join them by the words or. So let me give you a bunch of examples here in the same box to illustrate this point for us. Okay, and I'm going to start by just drawing you a picture. So let's say I give you a number line that looks like this, and let's say I give you 0 here, and I give you -2 here, and I give you 6 there. Alright? And I put a open dot over the -2, and I put a closed dot over the 6, and I am interested in only the portion, or only the numbers that are strictly between -2 and 6, but I can include the 6 and not the -2. Okay, so how would I describe this? Alright, this little section right here, how would I describe that? Well, I would describe it like this, right? I would say in set notation, I would say every x in there can be described as the following, right? The low end of this thing is -2, right? And the high end of this thing is what? If the low end is -2, what's the high end? The high end is 6, okay? And 6 is strictly less than any number that I could pick. And any number that I could pick will be less than or equal to the number 6. So this right here is a compound inequality. So what we're saying are these two statements into one. We're saying that x is greater than -2, and at the same time, we are saying that x is less than or equal to 6. You guys see that? We're saying these two statements, right? And the way that we would write these two statements is in that set notation up above, right? We're saying -2 is less than x, which is less than -6. Now notice that this part of this, so x is less than or equal to -6, that looks just like that right down there with the yellow. You guys agree with that? Those two things are the same. However, do you notice that this part and this part, right, this x with that, have been switched around? Do you see that? Why is that the case? Are those two green highlighted segments saying the same thing? They're saying the same thing, right? When we write it as one compound inequality in set notation, like we did up top there, we write it as if the x variable is between -2 and 6. So we want any number between -2 and 6. But really what we've done is we have combined these two distinct inequalities. That's the definition, right? Two distinct inequalities joined by the word and or the word or. So that's an and variable, okay? Let me give you an or one, okay? Let me give you another example right down here. So I'll give you another picture. Let's go back to 100%. Let's say I give you this picture here. Here's a number line, okay? And I give you 0, and I give you 5, and I'm going to color in 5 and shade to the right, and I'm going to not color in 0 and shade to the left. So I want this statement, that statement there. Okay, can you give me two distinct inequalities that I could write for this statement here? Just give me the one on the left, like the 0. How could I, if I were to cover up, right, pretend I couldn't see the 5, if I just had the one on the left, what inequality could I write to describe that? Are we going? X is strictly less than 0. Good. Okay, now give me the one on the right. Greater than or equal to 5, okay? So now, can you think of a number that is less than 0 and bigger than or equal to 5? No, it's impossible, right? Let me rephrase the question. Can you think of a number that is less than 0 or greater than or equal to 5? Yes. Okay, so you see the difference between and or? Very, very strong difference, right? So this is joined by the word or. This is an or statement, all right? The one up above, the first example, was an and statement. So how do I take these two and write it in set notation? Well, I would just say any x value such that x is less than 0, or you can actually just write it in x is greater than or equal to 5. So this is what we want to be able to read, write, and understand. Okay, so our task right now is we're going to solve and graph this on a number line. This is a compound inequality. The reason this is a compound inequality is because I have two distinct inequalities joined together at the same time. So you solve this just like you would a normal equation. So if I want to isolate my variable, I'm going to add 4 to all sections of my inequality. So notice I have 3 sections. I'm going to add 4 on the left, I'm going to add 4 in the middle, and I'm going to add 4 on the right over here. So I'll take those lines away just so you can see. Alright, so if on the left hand side, negative 3 and 4, how much is that worth? That's worth 1. Okay, less than or equal to x less than negative 1 and 4, how much is that worth? That's worth 3. Okay, good. So does this make sense? Are there numbers that are between 1 and 3? Yes, there are. That makes total sense. So is this an and statement or an or statement? This is an and statement. Very good. Very good. So here we go. This is how we would graph it on the number line. All right. You have to give me 3 numbers now. Which numbers do you have to give me? 1, 0, and 3. So here we go. Here's 0. Here's 1. There's 3. You gotta give me 3 of them. Okay. Always gotta give me 0 on the number line so we know. Okay. Above the 1, I put a circle and I shade my circle in. Why is that the case? Because it's less than or equal to. Good. And then up above the 3, I put a circle, but I do not shade it in. And I want all numbers that are between 1 and 3. So we're looking for this right here. 1's included, but 3 is not. Just to give us another heads up, how would I write this in inequality notation or set notation with inequalities? What would I do? Okay, we'll go for it.
So you put this
Mm-hmm.
X,
Mm-hmm.
and the dash followed by
Mm-hmm.
1 is less than or equal to X, less than.
Good. Does it make sense that we have a set of numbers to answer this question? Does it make sense that we have a collection of distinct elements? Right? That's what a set is, a collection of distinct elements. Yes, right? Because we have 1, we have 2, we have 2.5, we have 2.999, we have 1.873, right? We have an infinite amount of distinct objects that we can collect, so it does make sense to talk about it in set notation. That's why we do it. Does that make sense? Okay. All right, this is obviously an or statement because the or is written in there. So we know that. So right off the bat, we know we're going to have an or statement. So what we do is I like to draw a line right down the middle here, and we solve simultaneously both of our distinct inequalities, the one on the left and the one on the right. No big deal. So we solve them one at a time. So let's work with the one on the left here, okay? So I'll change colors here. So we're going to subtract 2. I think that's a good idea for the first part. So we're going to have 3x is less than negative 9. I'm going to divide by 3 on both sides. So I'm going to get x is less than negative 3. You guys agree with that part? Did I do that right? Yes, you guys agree. Okay, on the right-hand side, my first move would be to what? To do what? Let's subtract 5 from both sides. I'm with you. I like it. So I'd get negative 4x is strictly less than. 1 take away 5, how much is that worth? Negative 4, very good. I'm going to divide by a negative sign. I'm going to divide by a negative sign. So I'm going to reverse the direction of the inequality as discussed yesterday. So now x is going to be greater than what? Positive 1. Awesome. So look what I have. Can you think of numbers that are less than negative 3 or bigger than 1? No? You can't? Yeah, or you can, and you cannot, right? There's no number that's less than negative 3 and at the same time bigger than 1. That's impossible. But we can draw this inequality on the number line. So here we go. Here's my number line. I need a 0. I need a negative 3, and I need a 1. Above 3, I have an open dot. I'm shading to the left. Above 1, I have an open dot, and I am shading to the right. And there is my compound inequality graphed on the number line. How would I write it as a set notation? What would I do? All numbers x such that what? What has to be true?
Won't you just write X is less than negative 3 or X is greater
That's exactly right. I would write exactly that. Nice job, Brandon. And that would be my set notation. Very, very simple, very, very straightforward. So we're going to discuss how to transpose an inequality to an interval and vice versa, okay? So we'll start off with something that we've already done before. So we'll start off with, I'll do green, okay? If I have this inequality, x is greater than 3, okay? X is greater than 3. There's another way that we could write this using an interval notation, all right? When I have x is greater than 3, as you see it right now on the screen, that's an inequality because there's an actual inequality in the statement, right? But for an interval, the other way that I could write this is like this. I could use an open parenthesis, 3, comma, positive infinity, open parenthesis. Okay? So these two statements right here are saying the same thing. They're just written differently. Okay, the one on the left is inequality, right? So I'm picking any x that's bigger than 3. The one on the right says now I have an interval for which that x can fall into. It has to be between 3 and infinity. A couple of things to note. Whenever you're dealing with infinity, you never ever put a closed bracket on it. Okay? I'll talk more about that in a second, right? The reason is because if you put a closed bracket on it, that means you're actually including that number. There's no way you can actually include infinity. So you never put a bracket on it. You always use a parenthesis with it, okay? What if I did this one? What if I did x is greater than or equal to 5? Okay, this is an inequality. I want to change it into an interval. So I would use a bracket now. The bracket indicates that 5 is part of the interval. So I go 5 to infinity with an open parenthesis. So notice the difference, right? When the number is included in the interval, you use a bracket. When the number is not included, you use a parenthesis. We never put a bracket on infinity. Okay? Also notice that the way that the interval is read, it reads from left to right. So I'm going from 5 to the right out to infinity. Okay? Watch that because this is going to play an important role right now. What if I gave you this one? X is strictly less than 7. That's an inequality. X is less than 7 because there's an inequality there. How do I write that as an interval? Well, here's how we do it. We say open parenthesis, we say negative infinity, comma, 7, parenthesis. Notice this is different, right? This is from, I go from negative infinity all the way up to 7. And notice how it's read from left to right, okay? So what would be the wrong thing to do? The wrong thing to do would be this, 7, comma, negative infinity. That just doesn't look right, okay? That doesn't make sense to us. We put the leftmost number on the left to right, just like we read a number line from left to right. So this would be the mistake. So don't write it like that, okay? All right, what if I gave you this one? X is less than or equal to 13. How would we write that in interval notation? Will, what do you got, buddy?
You do the parentheses.
Yep.
And then negative infinity.
Yep.
To
And then we use a bracket or a parenthesis?
use a parentheses.
No.
No, use a bracket.
We use a bracket. Why do we use a bracket?
Because 13.
Because 13 is included. Very good. Okay. What about this one here? What if I said this? What if I said 3 is less than or equal to x, which is strictly less than 10? That's a compound inequality, isn't it? Okay, how would I write this in an interval? Well, 3 is included, so I would have a bracket. I would put 3, comma, 10. 10 is not included, so I would not put a bracket. I would put a parenthesis. You guys see this? Do you see how one transposes into the other? Okay. Let's do another one here. What if I did this? What if I did 5 is strictly less than x, which is less than or equal to 20? Okay, that's an inequality. It's an and statement, so I would put a parenthesis, 5, comma, 20, bracket. So far, so good? Okay, now let's do the or statements, right? What if I have x is less than negative 3, or x is greater than or equal to 4? How would I write this in an interval notation? Well, I would start with the one on the left, right? The one on the left says I go from negative infinity all the way up to negative 3, and I use parentheses, and then I just put the word or between them, and then I would say from 4 out to positive infinity with parentheses. Okay, so let's practice this, right? -4 to 6. Well, what interval are we talking about on the number line? Well, this is what we're talking about, okay? So here's 0, here is -4, here is 6. 4 is included, 6 is not, and I'm talking about that interval right there. The interval that's between -4 and 6, where -4 is included and 6 is not. Alright, so -infinity to -1 or 2 to positive infinity. Okay, let's graph that on the number line. So here's my number line, and I need 0. So here's -1, and then here would be 2 over here. So 0 is part of the interval, and I want everything to the left. So that's going from -infinity up to -1. And then I want everything from 2 to the right. So this is how we would say either the interval from -infinity to -1 or the interval from 2 to positive infinity.